Now in this video lecture we will go through relation between nearest neighbor D, edge of the unit cell, right, edge of the unit cell A, we call it A, and radius R of an atom, right, or the particle that is kept here. So we would be going through the relation between D, A and R, right, for these three unit cells: simple cubic, face centered and body centered. And remember, in these types of relations you will get numericals, so this is important, right? So the relationship between D, if you look at this, what it looks like exactly is, we know that this is a open structure, right? In closed packed structure, these two particles are actually touching one another. This is how it looks like. These particles A and B, this is how it looks like. So this is your center, this is your center, right? This is D, right? This is the distance between the particles. D is the distance between the particles, right? And edge of the unit cell, this edge, right? This complete edge from here to here is A, right? Now what is the relationship between nearest neighbor D, right, and edge of the unit cell A, right? This is what we have to find. Now we know that D is equals to AB here. If you look at here, we have this D, which is the distance between these two particles at A and B. D is equals to AB, right, which is equal to this edge of this unit cell A, right? And if you want to find the radius R, right, radius R of the atom, what it means is, this is the radius R, this is the radius R, right? This, if you look at here, this is the radius R. Now this radius, right, is equals to, this is half of this, right? This radius is half of this, and this is equal to D, right? So we can write R is equals to D by 2, right? So this is the relationship between radius R and the distance between nearest neighbor D, right? These are two nearest neighbors, distance between them is D, right? And if R is the radius of this particle, right, then this R, you can see from this diagram, this is half of this D, right? This is the relation. And we know distance D is equals to AB, the edge of the length, right? Now let's come to the second diagram, this FCC. In FCC we will find this relationship. We know that FCC is face centered cubic, where we have one particle at the center of every face, right? So we have particle here, one particle here, one particle here. Since this is FCC, so we have one particle at the center of this face, right? Now let's consider this triangle. So distance between the closest neighbors, this and this, would be D, right? And this is AC. This is AC, right? So your AC is this D is equals to half of AC in this, right? In this case, D, right, we said, let's write here, let D be the distance. This is for all the three cases, distance between, D is the distance between nearest neighbors, right? So D is the distance between here nearest neighbors, that is this and this, the distance is D. And you can see this D is half of this AC. So D, distance between nearest neighbor, is half of AC, right? This is the one relation that we got. So now if you consider this triangle A, B and C, right, right angled at B, right? Then we will apply the Pythagoras theorem. AC square is equals to AB square plus BC square. In this triangle, right, in triangle ABC, right angled at B, we have AC square is equals to AB square plus BC square, right? So AC is equals to under root half of AB square plus BC square, right? This is simple mathematics. So we know that AB is your edge of unit cell, which is A, and BC is also equal to A. So we have A square plus A square. AC is equals to under root 2A square or under root 2A. Now AC is your D by 2. Sorry, AC is your twice of D. Twice of D is equals to under root 2A. Therefore, D is equals to under root 2 upon 2 dot A. Right? If you multiply it with root 2 and root 2, it will come out to be D is equals to 2 upon root 2 into root 2, 2 upon 2 root 2 A, which would be D is equals to A upon root 2. This is the relationship between D and A. Right. So D is equals to AD is equals to AB square plus R is equals to A upon 2 root 2. I'm sorry. There is D is equals to, in the first equation we have got this right here. D is equals to D is equals to root 2 upon 2 dot A. This is what we have got, right? D is equals to root 2 upon 2A, right? Or this can be written as A upon root 2, right? D is equals to A upon root 2. This is the first relation that we got. D is equals to A upon root 2. Now we know that now we have to find for this radius, right? We know that R is equals to, if you look at this, these are the diagram, then R is equals to, we can write it over here, R is equals to D by 2, right? R is equals to, we have D by 2. So A upon, it will come out to be A upon, the value of D is A upon root 2. So this would be A upon 2 root 2, right? So we have two relations. One is D is equals to A by root 2 and R is equals to A upon 2 root 2, right? These are the two relations that we have now. This is for FCC, relation between radius of the particle and edge of the length, relation between distance between the closest neighbors and edge of the length, edge of the unit cell, I'm sorry, right? This is simple, very simple mathematics. This is the distance between the closest neighbors, right? And this is D, right? So R would be, so we know that D is equals to half of AC. This is one relation. Now if we talk about, if you take these two, this would be, this is what it looks like, right? This is your D, right? And the radius of this particle is R, right? So we write R is equals to D by 2, right? This is what we have mentioned here. R is equals to D by 2. We got it from here. This is D, this is R. So R is equals to D by 2. It's half of this, this length is half of this. This is what it means. Now if you take this triangle, this is your AC square is equals to AB square plus BC square, right? Simple mathematics. This is what you will get. AC is equals to root 2A. So AC is your twice of, AC is twice of D. right? From here AC is twice of D, so we'll put the value of AC and this is what you will get, right? And from this relation you will get this. This is simple. Right? Now we'll look at BCC, this one. In BCC we have distance between nearest neighbors. Again we'll consider this. In BCC we know we have particles at all the 8 corners of the cube and we have one particle at the center of this cube. So this is the particle at the center, this and this, and this is the triangle that we have considered, right? Triangle A, C and this D, right? So this is again distance between these two particles is D, right? And this D is equals to half of CD, right? If we consider this triangle, D is equals to this is your D, right? And this D is half of CD, right? This is for BCC. D is equals to half of CD, right? Now again we'll apply Pythagoras theorem, right? In ABD right angled at B, right? In this triangle we'll consider this ABD, right? ABD right angled at B. So we have AD square, right? In triangle ABD, right? This right angled at B, we have AD square is equal to AB square plus BD square. Therefore AD is equals to AB square plus BD square, right? So this would be A square plus A square, which would be root 2A, and your AD is equals to, this is your AD. Now we will find the value of, we have got from here, we got AD is equals to root 2A, right? Now we will find the value of AD from this triangle, right? From triangle ACD, right? From triangle ACD right angled at A, we have CD square, right? From this triangle. Now we will consider this triangle ACD. In triangle ACD we have right angle at A, we have CD square is equals to AC square plus AD square. Therefore CD is equals to AC square plus AD square. AC is your, AC is equal to A square, right? AC is your H, A square, and AD is from here. AD square is your 2A square. 2A square, this would be 3A square. So we have CD is equals to, this is the relation, right? CD is equals to under root A, and I'm sorry, root 3A. Now CD is, we know that CD, we have already found the relationship. CD is twice of 2D, right? Or we have mentioned in the beginning that D, this is half of CD. D is half of CD, so we'll put the value of CD from here. 2D is equals to root 3A, right? D is distance between nearest neighbors, so D is equals to root 3 to A. This is the relationship between D and A, edge of the length, right? D is equals to root 3 2 upon A, right? And we know that R, if you consider these two, whenever you want to find the relationship between R, right? Whenever you want to find the value of R is always, if whether you look here or here, R is always equal to, if you look at these two circles, R, it's similar to this. This is the, R is the radius of this particle and R is the radius of this particle, right? Since they are touching one another, so R would be equal to half of D. R is half of D. So if I'll put the value of D here, D is equals to 2r, right? So you have r is equals to d by 2. D is equals to, putting the value of d from here, root 3 upon 2, right? Root 3 upon 2 into 2a. So this is equal to root 3 4a. Therefore we have r is equals to root 3 4a. This is the relationship between radius r and edge of the length, right? So I hope all this is clear to you. This is simple mathematics and you will get numericals on this. I'll repeat, just in order to do these calculations, you just have to consider that these particles actually touch one another, right? So we have considered that d is the distance between d is the nearest distance between the particles, right? And if you look at this first diagram, this is in closed packed structure, these two actually are touching one another like this, right? These two are touching one another. This is your distance d and this is your r, is the radius. So r is equals to d by 2, right? So this is the thing that we have done in all these three. R is equals to d by 2 here, r is equals to d by 2 here. So what you will do is you will find the distance d, right, relation between d and a, and then you will put the value of d here to get the relationship between r and a in all these two cases, right? In this case you have mentioned that d, right, since FCC has one particle at the center of every face, so this is the triangle, right? This is one triangle. So this distance is half of AC. This distance is d. So d is equals to half of AC, right? Now this is the triangle that you will consider. Simple Pythagoras theorem. You have found the relation between d and a. You've got this. So put the value of d here. This is what you will get. Right? Similar is here. This is again particle at the center. So this is d. This d is half of CD. Right? Now if this is at right angle triangle, we will apply Pythagoras theorem. We will get AD, right? From here we get AD is equals to this. We will consider this triangle first, ABD, right? In ABD we got the value of AD. AD is equals to under root 2A, right? Under root 2A. Then we will consider this triangle, this ACD. From here CD square is equals to AC square plus AD square, right? The value of AD square we have got from here. We have already done this. So this would be root 3A. Then you will put the value of, you found the relationship first between D and A. Then R is equals to D by 2. Then R is equals to root 3 4A, right? This is simple. Now you will get some numericals on these. Just remember, the numericals will say whether the crystal, whether the solid crystal is FCC, BCC, all this, right? So you can practice numericals. It will become more clear to you. Thanks.